have just seen an assortment of metal items of common use. You all know metals are hard and cannot be easily formed into these products. Then one wonders how this is done. Each one of these items needs a special process of manufacture. And this brings us to the topic of metal forming. The topic of metal forming is quite vast in itself, but our purpose here is to understand the concept and appreciate the usefulness of these processes. Some of the metal forming processes under the bulk deformation processes are forging, rolling, extruding, wire drawing, and others such as sheet metal working. Now let us understand the principles underlying these processes and how they work. To start with, we will deal with principle of forging. In the forging process, material having some malleability is worked on by compressive forces. The result is that material size decreases in the direction of compressive forces and spreads in a direction lateral to compressive forces. This process, when applied to production of a component, should result in a component of desired shape and size. Forged jobs are commercially produced on forging machines. Now let us understand the process of forging by graphic animation. The job is placed on the lower die. The lower die is clamped to the machine table. The upper die is mounted on the ram. The ram moves up and down, thereby bringing the upper die heavily on the job. This repeated striking of the job causes it to be compressed. By this process, a variety of items of utility are prepared. These items range from rivet, bolt, spanners to connecting rod, C-clamp frame, horseshoe, hammerhead, etc. The main advantage of forged items over cast items is their higher strength and durability. The materials which are extensively used in forged components are iron, carbon steel, alloy steel, stainless steel, copper alloy, aluminum alloy, magnesium alloy, etc. Another important metal forming process is rolling. In this process, we will learn about its principle and items produced by this process. First of all, we will study the principle of rolling. In this process also, compressive forces are applied on the material having some malleability. The application of compressive forces is done through rotating rolls. The rotating rolls bite into the material and pull it in between the rolls and then pass them out. This results in compression of the material in the direction of the compressive forces and spreading of the material in the lateral direction. Thus, we can say that rolling is a forging process of the continuous type. Let us see how this process takes place. Here, material having a property of malleability is put in between rolls. The upper roll rotates anti-clockwise while the lower roll rotates clockwise and causes the material to be pulled in from the left and pushed out to the right with reduced dimensions. We see that the speed of feeding into the rolls is lower than the speed of outflow from the rolls. Complete passing of the material in between the rolls is called a pass. A large variety of sections are produced by this process. These sections are round, square, rectangle, plate, 2, hexagon, T, angles, and from, channel, rail, joists, 2, bridge rail, Z, troughing, tube, etc. These sections find a variety of applications ranging from structural members of buildings to structural members of automobiles and aircrafts. Commonly rolled and re-rolled materials are iron, carbon steel, alloy steel, stainless steel, copper alloy, aluminum alloy, magnesium alloy. Another process for producing complicated sections and structural members which cannot be produced by rolling is the process of extrusion. In the process of extrusion, we will look into simple direct extrusion with emphasis on the principle of extrusion and sections produced by this method. Now let us look at the principle of extrusion. The principle involves in keeping the material in cylinder. The material is pushed by means of a piston against a die. With the pressure force, the material is first upset to fill out the container and then emerges out through the die. Let us now see the process by which the material is extruded. The material in its plastic state is kept in the cylinder. It is then pushed by means of a piston against a die. With the pressure force, the material is first upset to fill out the container and then emerges out through the die. The process is continued till a small sized stub of material is left, while most of the material has taken the extruded form. Let us look at the bar sections produced by this method. These are solid, semi-hollow, and hollow. The material commonly used for extruding are aluminum alloys, magnesium alloys, copper, lead, brass, and steel. Shapes extruded out by this process are classified usually according to their complexity. These are solid-shaped products, semi-hollow products, and hollow products. Now, a question arises regarding the comparison of products produced by this method and the method of rolling? The answer is that products produced by the method of rolling are less intricate and higher in strength than the products produced by the method of extrusion. Another method of metal forming is wire drawing. In this process too, attention is directed towards its principle. A rod or wire of larger diameter is pulled through a die plate. The hole in the die plate is smaller than the size of the rod or undrawn wire. Thus, when the rod is pulled through the hole in the die plate, it causes a reduction in the diameter of the rod. Let us now see how the process of wire drawing takes place. Round wire of large diameter, when pulled through a smaller hole in the die plate, is reduced in size to diameter as shown. By this process, wires of non-standard dimensions can also be obtained. The wires obtained by this process have much higher tolerances and better surface finish. The process is especially useful for producing electrical wires of plain carbon steel, alloy steel, copper and alloys, aluminum, and nichrome. This completes the method of metal forming, its principle and processes. Let us now quickly review the process of metal forming. There are 4 basic processes of metal forming. These are forging, rolling, extruding, and wire drawing. Principle of forging. In forging process, material having malleability is worked by compressive forces and a component of desired shape and size is obtained. Forgings have the advantage of higher strength. Items obtained by this process have no cracks or ruptures in the material. A variety of components are produced by forging processes like rivet, bolt, spanners, connecting rod, C-clamp frame, horseshoe, hammerhead, etc. Principle of rolling. In rolling, compressive forces are applied on the metal having some plasticity by means of rotating rolls. The rotation of the rolls forms the feeding and the ejecting mechanism for the metal. It is essentially a continuous forging operation. A large variety of sections are produced by this process. These sections are round, square, rectangle, plate 2, hexagon, T, angles, and from, channel, rail, joists, 2, bridge rail, Z, troughing, tube, etc. Principle of extrusion. In extrusion, material in plastic state is pushed against a deforming die and bars of most complex sections are obtained. If the product emerges in the same direction as the movement of the piston, it is called direct extrusion. The items produced by extrusion are solid, semi-hollow, and hollow. Principle of wire drawing. In wire drawing, a wire of larger dimension is pulled through a die plate having a hole of smaller dimension, thereby the pulled wire is reduced. The process has the advantage of obtaining non-standard dimensions, better surface finish, and closer dimensional tolerances. This brings us to the end of the study on simple concepts of metal forming. Goodbye.